Hello, thank you. Thank you for the introduction. I am Stefanie Brodie, as was stated. I am a research program specialist at DDOT, the District Department of Transportation. And we also had Kiana interning with us quite recently. She's a PhD candidate at the University of Maryland. And while she was interning with us, she helped to set up numerous Python scripts to understand the dockless demonstration period. And how many of you guys have been in DC and have seen the scooters that have been out in the streets? All right, how many have ridden them? So thanks for participating in the dockless demonstration period. I'll give you a little brief introduction about what it is and why we have that going on. And then I'll start talking about some comparative analysis that looks at the dockless demonstration and the capital bikeshare bike sharing system that we've had in DC for quite some time. And then Kiana will come up and she'll talk about some other analysis that we did, the idle time analysis, labeling dockless trips to understand travel behavior, a hotspot analysis, as well as showing you some visualizations that we did to understand where trips are coming from and going to. So back 10 years ago, DC launched the first public bike share system in the North Americas. And this was Smart Bike DC. A couple years later, we upgraded to Capital Bike Share, which is what you see now out there. We have over 400 stations within the metropolitan area. Last year in September, we added dockless bike share to that mix. This allowed, through a permit process, private entities were able to rent out bicycles to the public in public space. In March, so not long after the dockless bikes came, we got dockless scooters. And these have been in existence since March in DC. And at this point in time, we have mainly scooters. We have 5 companies operating under the demonstration period. 4 of them are scooters, and 1 is an e-assist pedal bike. So we wanted to be open to this dockless demonstration period because we want to increase modal options in the District of Columbia. But we want to make sure that we're addressing some of our primary goals, like ensuring safety and increasing active transportation. So in order to understand if this additional mobility option is doing so, we wanted to do an evaluation along with the demonstration period. So we had a couple of key things that we wanted to find out. Is the dockless demonstration period, are dockless options increasing active transportation goals, or increasing active transportation in line with our goals? Can we ensure that this is adding to the safety of our transportation system? So are these systems safe? Also, we want to have a demonstration period so we can gain some public input, so we can understand what the public thinks about them, because we are serving the public. And finally, we've been managing bike share for 10 years now, but the dockless options are new in DC, new across the country, and new in a lot of global markets. So we want to make sure that we are understanding how we can establish a management system for this program. In terms of managing the program, we, as I mentioned, have a permit that companies have to abide by, and there are certain rules in that permit. One of those rules being that they have to provide data. So each company has to provide a public API that shows where the bikes are, and the bikes or vehicles, bikes or scooters, at any point in time that are available for rental. And that allows people, civic hackers, as well as people who are developing apps, and just general public who are interested in the system to get information about it. We also have monthly reports that provide trip origin and destination data, and that allows us to understand how we might plan better for our transportation system, as well as providing for infrastructure for the dockless vehicles. And getting this data set is really the beginning. So we've had other trip origin destination data sets, and this is another big, large data set that we have. What we're trying to do is find ways that we can use this data to better understand our planning efforts, as well as evaluate the program. And this is the beginning because there's also data that's coming in from TNCs, which is your transportation network systems, the Ubers and Lyfts. And we want to be preparing for automated vehicles and autonomous vehicles, which will also be providing data that can be used for planning purposes. Currently, we also have cameras and sensors in the field in DC that can provide us information on safety, which is, again, our #1 priority. So we want to be able to use that as well. And then there are data sets across the district and different agencies that can provide insights that will be helpful for DDOT going forward as well. So we have a lot of data that's out there, and we're just scratching the surface of how to use that data to improve efficiency and safety in transportation. So in this presentation, I'll go through some analyses, and so will Kiana. The first one I'll talk about is a comparative analysis that looks at dockless bike share and comparing it to capital bike share. Then Kiana will talk about an idle time analysis that looks at the impact of dockless on public space, because DDOT does manage the public space. We'll also talk about how we label trips to understand travel behavior patterns. And then finally go through a hotspot analysis that we use to identify areas for more parking infrastructure for bicycles and also scooters. Finally, we'll do some visualizations that look at the trip origin destination data more rawly, and to understand where trips are going from and coming from and going to. So I'll start with the comparative analysis. So what you have here are the number of monthly trips that were taken on capital bike share and dockless vehicles. So again, the program started in September last year, and what you'll see is that around March, when the scooters came, we start to see an uptick on ridership, and that's because the scooter trips were dramatically higher than the dockless bicycles. But one key takeaway again is capital bike share has a much higher ridership base. It has a lot more vehicles and also a lot more stations. This shows a heat map matrix of the rides going to and from different wards of the district. So there are 8 wards in DC. Ward 2 is the central business district, downtown by the mall and the monuments. Ward 7 and 8 are across the Anacostia River, and those are areas that are primarily minority and low income. So what I want you to take from these, you have capital bike share on your left, and that's your left, and dockless vehicles on your right. So what's interesting between these two is there's a comparative distribution across the district for both options. However, many of the trips, most of them in fact, are starting in Ward 2, which is downtown, the central business district. Between capital bike share and dockless vehicles, if you look at the trips that are starting in Ward 7 and 8, there's a little bit higher percentage in the areas across the river. So that's interesting to note, because one of the things that we want to make sure that we're doing at DDOT is serving the entire population of the district. So it's important that we're understanding the benefits to having these systems and where they're going. We also wanted to know what kind of usage trends happen across the week. So here we have the usage trends over the course of the day for weekdays and weekends, because travel patterns are different on weekdays versus weekends. So if we look at the weekdays, each line represents a different mode. You can see that for capital bike share members, those are the people who have memberships to the station-based service. And for e-bike riders, these two member groups tend to have peaks in the morning and in the evening, which denotes a commuting pattern. On the weekend, we see that most of the modes are similar, with some concentration of trips for scooters within the daytime hours. We also wanted to look at the spatial distribution of those trips across the day. So this is an example of morning peak time commuting, or morning peak time usage for capital bike share members, and then capital bike share casual riders. So casual riders are those who might have taken one trip. They might buy a pass for a day, but don't have memberships. So what you can see here is The casual riders are typically concentrating their trips in the morning downtown by the monuments, by the museums, where the members are more spread out. And that also harkens back to the last slide where we see the commute patterns with the members. If we then look at the dockless vehicles, both the bikes and the scooters, we see a more distributed trip pattern for the morning. We do see kind of the hotspot downtown in the areas around the mall, but we also see that it's distributed more broadly across the residential areas. And that's because they're not constrained to the stations that Capital Bikeshare is. To understand some more about how these trips are distributed across the week, we looked at each of these modes and found out that, as we suspected, they're fairly distributed across the week. However, casual riders are typically, casual Capital Bikeshare riders are typically doing most travel on Saturday and Sunday on the weekend. And another kind of outstanding outstanding issue with the casual users is the trip duration. So these users are typically riding the bikes for longer. So we see average trip duration between 10 and 12 minutes on most cases, except for the casual riders, and their variance is also much larger. So that's a little bit of background on the dockless program, Capital Bikeshare, and how DDOT tries to encourage active transportation, and kind of what we found just looking at the data generally. And I'll pass the mics over to Kiana to talk about the analysis more specifically.
So, hello everyone, thanks for coming to our talk. So I'm going to continue talking about some other analysis that we have done in DDOT on dockless bikeshare and scootershare. So the first analysis, I'm going to talk about idle time duration. So basically idle time duration refers to interval between the end of a trip and start of a trip with the same vehicle. So basically this was very important for DDOT because they initially received several complaints about these bikes are parking for a long time in certain areas, especially blocking the pedestrians or disabled people. So we wanted to find out in what extent this is true. And then this was used as a measurement for assessing the performance of the operators in maintaining this system in DC. And the other potential usage for this kind of analysis is going to be for locating where are the proper places for putting the biking racks, and also from operators' perspective, it's also important because it can help them to with their rebalancing operations in order to have a more efficient system that can serve many people. Like they can serve, they can increase the usage. So there are certain libraries that were used. I put them in the block for each section. So in order to calculate the idle duration, so we needed to sort the trips based on the operators, and then vehicle IDs and the start of the trip, and then a cleaning procedure was done to basically remove the irrelevant trips. So for example, if a trip was ended at a location and then the start of the next trip was far from this location, then it was removed. So basically this was basically resulted from the rebalancing of the system or some error in the data. So basically we were remained with around 67% of the dockless scooters data, and then around 71% of the dockless bikes. So this graph shows a part of our analysis. So basically this is the x-axis shows the time of day that the parking event happened or occurred, and then the y-axis shows the duration of the idle time. So basically the lower bound is 25 percentile and the upper bound 70% percentile, and then the line between is the median. So for example, you can see for dockless bikes, which is the green plot, you can see around 5 a.m. 25 percentile was around 2 hours, median was around 5 hours, and then the 75 percentile was around 10 hours. So you can see that the trend increased for the evening, which is intuitive because most of the bikes they are not going to be used during the night time. So this kind of increase you cannot see for scooters. So in general, you can see that scooters their idle duration is much lower, which can be particular because they are very popular. And then you cannot see the night time because the high idle duration during nights, because basically scooters are usually like mostly gathered because they are electric to be recharged. So basically the idle duration during night is removed from the data. So another analysis we have done was to see what percentage of trips had idle duration more than 6 hours. So these regions are single member district, which each of them has around 2,000 residents. Again, as you can see, so southeast of DC has a relatively higher percentage of trips with idle duration more than 6 hours. So these are Ward 7 and 8. But I'm going to show an interactive visualization which indicates that this doesn't basically interpret as high number of trips, because mostly most of the trips happen in Ward 2 and 6, which are located in city center, and there are not that many trips in Ward 7 and 8. So this is the same visualization for dockless scooters. You can see again that the percentage of trips with idle duration more than 6 hours is much lower than dockless bikes. So here it is a visualization using Shiny for locations with idle time more than 6 hours. So basically, you can select the time of day. For example, we pick 7, 8, and then we can choose dockless bikes. And if we zoom in, we can see that where are the locations, like a heat map of locations with idle duration more than 6 hours. So if you change that, you can see, for example, in this area, which is mostly a commercial area, you can see a high idle durations, which is intuitive. But when you, for example, move it to time between 4 and 5 p.m., you can see that the intensity of idle duration decrease. So okay, so now we will move to the next analysis. So in this analysis, we wanted to basically answer this question, that whether the behavior of dockless bikeshare and scooter share users is more closely related to capital bikeshare casual riders or members. So if you are familiar with capital bikeshare, you know that there are two kind of memberships. One is casual, which is a daily pass or 3-day pass, and then there is another one as annual membership. So in this part of analysis, we wanted to develop a classification model trained based on capital bike share data, because for dockless bike and dockless scooters, we don't have a label such as capital bike share as member and casual. So basically, we use two classification models, random forest and logistic regression, which random forest is an ensemble classification method, and logistic regression is a linear model for classification. And then we basically train this model using the capital bike share data from March till end of May for 2 consecutive years, 2017 and 2018. There are about 1,400,000 trips. These are just within DC trips, and however, the data set is highly biased towards the members, because usually in capital bike share usually like 70% of the trips are made with are taken by members and 30% by casual riders. To make the data balanced, we downsampled the data, and then we were left with around 700,000 trips. And then basically the 20% of this data was used as a test and 80% for training. Then we use the model developed on dockless bikes and dockless scooters to label their trips. So for dockless bikes, we had around 70,000 trips, and for dockless scooters were around 180,000 trips. So the features that were used for training the model was start and end location, which was mapped to single member district level, duration of trips, start time of the trips, and day of the week. So in order to evaluate the model, F1 score was used. So you can see that random forest has a slightly better F1 score. And then the table on the on upper level shows the confusion metrics for both logistic regression and random forest. You can see that for random forest, around 63,000 out of 76,000 trips were labeled correctly, and this number was around 64,000 for the members. And then in the next table, you can see the model prediction for dockless bikes and dockless scooters. You can see, for example, for random forest, the model predicted that around 60% of the trips are by members, and for dockless scooters, this is around 65%, which shows that the mostly by this classification, the trips were more aligned to members and commuter trips. So the last, yes?
So those numbers, are those reported on a downsample, like in the test set? Did you also downsample?
You mean for logistic regression and random forest?
This number, like the data that was run up, was that downsampled or not?
The last one?
Yeah, this table right here.
So basically you don't have, so this is the unsupervised learning, so you don't have label for this. So basically you don't have label for the dockless bikes and dockless scooters. We use just, yes, we just use the model trained by capital bike share and then apply it on the data for dockless scooters and bikes. So we don't have the real label of them.
So that's saying out of the unlabeled points, 61.3% of them you found to be
Yeah, they were more similar to members then. Okay. So the last analysis was hotspot analysis. So as I explained, one of the major concerns about dockless vehicles was their improper parking in public places, blocking pedestrians and disabled. In this analysis, District Department of Transportation was interested in providing some biking racks in order that these dockless bikes can be parked in proper places, and also in general, as you might know, this kind of data is a very good source for finding out where most of the bike trips starts and where they are ended. So we kind of use this data for finding where is the hotspot locations for bikes. So in order to do this analysis, we use a density-based spatial clustering called dbScan, so to cluster the end trip of dockless bikes. So dbScan, as I mentioned, is a density-based clustering which uses two parameters, epsilon, which is a distance, maximum distance for clustering 2 points together, and then another parameter is the minimum number of points to consider points cluster. So these are the two parameters. Again, definition. So one of the advantages of this clustering is that this is robust to outliers. So basically, you don't need to cluster every point, which was important in this case. One of the disadvantages was that it cannot consider clusters with different densities. And as you might know, these dockless bikes and dockless scooters, the trips are relatively, the density of the trips are really different in different wards. So for example, wards 7 and 8, they don't have many trips started or ended at them. So because of equity, we had to use different parameters for different wards to basically find candidate locations and across DC kind of uniformly. So we tested different numbers. As you can see, when you change the numbers, the number of clusters that is found by the clustering algorithm change. For example, if you increase the minimum number of points, the number of cluster it can be found decrease. So we kind of played with these numbers, and then we come up with 25 meter as epsilon. And then for different wards of DC, you can see the 8 wards of DC, we use different minimum points so that we can have candidate facilities in each of the wards. So, and this kind of shows the final so the gray point shows the end of the trips, and then the red point shows the center of the clusters, the points that are basically closer to the center of the clusters. And you can see, because of using different numbers, basically the densities are different across the DC, the density of the clusters. There are other visualizations. So another method for hotspot analysis was hexagonal binning. So this is another method for visualizing a large data set when you have a large set of data points overlapping each other. So again, this is by providing a grid over the map and then basically counting the number of trips that were inside of each hexagon. So this is another visualization for showing which areas have more dense end of the trips or trip starts. So these are two other visualizations. So the first one is the heat map of start location of trips versus time of day. So here again you can select the time of day and then you can zoom in to see where are the locations that usually trip starts. And the other one is basically the chord plot. So here it shows the inflow and outflow from each of the wards. So you can select the time of day and then the ward number. And then this chord plot shows basically, so this is ward 1, and this part shows the what percentage of trips basically coming out of the ward 1, and this part, the white part, shows the which percentage of the trips are coming into the ward 1. So basically this is our end of presentation. Thank you everyone for coming. Yes.
Are you like pinging the dockless API?
So you mean where the location of the bikes are?
Yeah, like the data you're getting, is that
from
the
no.
API?
So no, it's not from API. So the data we used here is just trip data provided by dockless operators. So they had to provide the monthly reports of the trips. So basically the trip data included the start location, end location, and then some distance measurement and
Time and date.
the time of time of the day. Yeah.
Yeah, so like they have an app associated with this, right? Like where users might take out their phone to try and find a bike, right?
Yeah, they have.
So each company has an app that they use that you can rent the vehicles through. And then also we have an API, a public API that they feed us that's available to the public that shows similar information that shows where all the bikes can be, where all the bikes that are able to be rented are.
Yeah, so I guess my question is that if these companies are collecting data about the apps, like where users are opening their apps, could you potentially use that as like a metric to see like where users are trying to open up, or where users open up their app to try and find bikes, and where potentially they didn't get a bike because none was available?
Yeah, so so we don't receive that data. Another thing that like we wouldn't want to have that data necessarily, but one of the questions we asked initially was kind of the false open rates. Like if you open the app and you see that, okay, well, I can't use it, so I'm going to close it. Like, what does that say about the availability of the vehicles? One thing I didn't mention about the pilot is up until the end of this year, companies are only allowed to have 400 vehicles throughout the district. So there is a cap on how many vehicles, and which could influence kind of the availability.
So I think you may have already answered this, actually, but I'm curious if the companies give you any information on sort of like super users. Like I would imagine they would not give you any sort of like person identifiable information on the users of the product, but if they could give you any sort of like, you know, anonymized ID level information, like can you see if like there's like a certain subgroup that are like your heavy users, or is it just all just trip based?
Yeah, so we are also receiving user data. Basically, it's a table that shows anonymized user number and then how many, user ID number, and then how many trips they're taking. So we get kind of an idea of if there are some people who are taking hundreds of trips during the month and some that are like tried it once. So we do have an idea of kind of the distribution of usage.
But you don't have about the age and sex of the
No,
users?
we don't get any demographic data.
Were the findings pretty consistent across companies?
It's the companies are very different. So if we think back to when we had the pedal bikes, there were 2 companies that were international. There were some companies that were national that were newer. They had different ways of interacting with the agency and with the city. They had different ways of interacting with their customers. So there was definitely variation across the companies. I think that at this point, over the course of the year, the companies are kind of aligned to a more similar pattern of operations, which is great for DDOT and great for, I think, the customers as well. But yeah, there's definitely differences across the companies just based on kind of how they operate.
How did you define again improper parking, and what kind of data you used to do that?
So we didn't have data on proper parking or not. We just used, we were interested in knowing how, like, what was the duration of the parking. For example, a bike is parked for 6 hours, 2 days, or something like that. So it's kind of assessing like how well maintained these systems are. So basically, operators are leaving them for themselves, or they are doing some rebalancing in order to, like,
Yeah, we weren't able to do any analyses to understand improper parking or not. That was one of the kind of research questions that we had in the initial kind of drafting of the research statement. What is improper parking? And one of the things that we identified is if it's not leaving a clear space in the public space, like if it's obstructing travel or if it's a hazard, a safety hazard. So those things are what we identified as improper parking, but there's not necessarily a way to track that with our data.
Do you know how like the scooters get recharged after they run out of battery?
it depends on the
Yeah.
you want to as far as I know, it depends on the companies. So for example, I know Lime Bike, they just provide, like, they are going to incentivize people to gather the scooters and charge them and then return them in the system in the morning. So they just pay, like some of them they just use like basically
Like gig economy.
yeah.
Okay.
But some of them they just gather them, like, and recharge them.
We could like, potentially develop like more optimized routes, right? Because they release the data of how much battery is in each bike.
Yeah.
So you could like potentially see like where bikes are out of battery, like in the same way that you did your exam.
Yeah.
So just do like just the bikes that are out of battery or something, right?
So you mean like, for example, vehicle routing problem for just gathering the bikes that they are not, like, they are, yeah.
It's like a very industrious juicer could develop an algorithm to identify areas where there's low batteries and then go out and collect those vehicles.
Yeah.
I thought there was another gap.
I do a lot of driving in DC. I live in Ward 3 and travel to Ward 7 every day. And one of the things that I notice is that the age profile of the users of dockless bikes versus dockless scooters is very different. And I think that at some point, if you mean to do research on precisely how safe these things are, it'll be impossible to address those questions without noting the age at which folks are using these. I mean, what I notice is in the afternoon, right after school is over, the use of, scooters is just, it's insane. I mean, I have a very worried kind of relationship with these things, like, how many more hazards do I have to deal with on the road? I think my brain is full. But, folks coming at you when they're 14 years old and, just hurling down the street with no helmets on a scooter, it's just something I see a lot on my way home from work.
Yeah, safety is a big concern for us. Scooters in the roadway as well as scooters on the sidewalk. So there's a lot of unknowns. It's a very new mobility option for DDOT, but also for the country. And there's a lot of cities that are grappling with how do we either enforce or educate or both around scooters.
On that point, what kind of data are you getting on accidents, and how are you cross-referencing that with everything else?
Yeah, so one of the things in the pilot is what data to collect. That's one of the things we learned, right? So we initially had an idea. We wanted some trip data. We wanted some information on safety, and we developed a data standard for that. Over the course of the year that we were collecting data, we kind of streamlined what we were asking for and asked for more details in areas that we were getting more questions around, and trying to flesh out the data that we needed to do the proper analyses. So over the first year, we were getting kind of aggregated numbers of incidents that were reported. So we were not really sure if they were crashes or if they were just incidents that the user reported to the company. As we move forward, we've asked for more details. So the severity of the incident, whether an NPD report was filed, and the location of the incident. So we're trying to understand better the impact that we're seeing on the road. Most of our safety crash data is coming in from NPD, Metropolitan Police Department crash reports. So that's typically how we understand incidents in all other modes. So we don't want to necessarily overburden this new mobility option, but we do want to get some more information since it is so new across the country. And
are you cross-referencing it at all with anything else? Are you finding anything interesting? Or?
So the data that we have thus far is pretty much just aggregate numbers. So we collected maybe a month or two of the newer set of data. So can't really do much analysis on it quite yet.
Okay, we have time for one more question.
So I saw that there are new regulations on the speed of the scooters right now based on safety concerns, and it's I think 10 miles per hour, which is becoming a larger concern for these companies. So branching off of the questions about collision data, are you guys trying to utilize some of that collision data to get more of an idea about how speed plays a role? Because it doesn't seem like the data you guys displayed to us has any idea about the speed.
Yeah, so it's not necessarily a new regulation. It's more of we're enforcing the regulation that was already there. So because scooters are considered a personal mobility device, similar to a Segway, there's always been on the books that they're not allowed to go over 10 miles an hour. So because some of the vehicles didn't have speedometers, and because we don't have people out there with speed guns giving tickets to scooter riders, we were putting the onus on the companies to find ways to make sure they're limiting the speed to 10 miles per hour. So that's kind of the newness of the regulation. So we're not necessarily collecting any data on the speed of the vehicles. And also, we've asked the companies, is it possible to, if there is an incident on an electric assist vehicle or an electrified vehicle, if they can provide the speed at which the vehicle is traveling if there was an incident. And that's something that they have not necessarily been able to do, so it's something that maybe in continued conversations and as their technology improves, that could be something that we add to the mix, but we don't have that data currently.
Great, let's thank our speakers for